Hello everyone, how are you all? I hope you all are doing very good. In today's class, we are going to study about power of lens. Power of lens. The video is framed in such a way that first we'll discuss the theory regarding power of lens and what are the formulas regarding power of lens and what are the precautions to be taken while solving problems on power of lens, and then we will go to a simple problems, two or three or maximum four simple problems. We will solve and give idea about the questions that are given in the textbook on power of lens. Then we will move to a difficult problems on power of lens. Okay, so next let us come to, without wasting any time, let us come to the concept now. What is power of lens? Power of lens means ability ability of a lens either to converge or diverge. Power of lens can be defined as ability to converge or diverge. If it is a convex lens, converging. If it is a concave lens, diverging. Okay. So now the ability of the lens to converge or diverge a parallel beam of light rays towards a single point, or else ability of a lens to diverge a parallel beam of light rays from a single point is known as power of lens. If you look at these three, I have taken three lens. For all the three, I have given parallel beam of light rays. See, first lens, if you see, thickness of the lens is very less here. These three are convex lens or converging lens. These three are concave lens or diverging lens, right? So thickness of the lens is very less here. What happened? The focal length of the lens is very high, right? If the focal length is heavy, it is unable to converge the light rays to a point which is nearby. If this lens has more power means more ability to converge. If this lens has more ability to converge, then all light rays will be converged at a nearer point, right? But this lens is unable to make the light rays converge at a nearer point. They are converging at a farther point, correct? So let us take, this is the focal length of this lens f1. Now if you look at this lens is able to converge all the parallel beam of light rays at a nearer point. F2 is lesser than F1. So this lens has more ability to converge parallel beam of light rays. So it is able to converge the light rays at a nearer point. Look at this lens now. This lens has still more ability. It has still more ability to converge the parallel beam of light rays to a point. So these all parallel light rays are converged at a point very close to the optical center of the lens. So this has more ability, this has less ability, this has still less ability. Imagine the power of this lens is P1, power of this lens is P2, power of this lens take it as P3. Okay, so if you look at the power and focal length, this lens has more power, so focal length is very less. And you look at the first lens, this lens has very less power and the focal length is very high, correct? So what can we say? We can say that power of a lens is inversely proportional to the focal length. Power of lens is inversely proportional to the focal length. And proportionality constant will be 1 here. Why it is 1 and all this derivation is not there, so we can directly take P is equal to 1 by F. In 10th CBSE we don't have y is constant k equal to 1. We can take directly P is equal to 1 by F. So this is how we got the power of lens formula. And what are the units? Units of power of lens is, we call it as dioptre. D-I-O-P-T-R-E. And it will be represented by D, capital D. The same thing can be explained for concave lens also. See, ability of the lens to converge, correct? See how much converging nature this lens has given. For all the three lenses, we have given parallel beam of light rays only. When we give parallel beam of light rays, these light rays are starting from a point which is far away, right? So the diverging nature of this light rays is less. Look at these light rays. How much diverging nature they have? They have maximum diverging nature. They have very less diverging nature. So ability of this lens to diverge the parallel beam of light rays is less. Ability of this lens to diverge the parallel beam of light rays is very heavy. That's why they are diverging at a great extent, and the point where those refracted light rays are meeting is very close to the optical center. That's why the focal length of this lens is this one, f3. Focal length of this lens is this one, f2. Focal length of this lens is this one, f1. Correct? Now if we look at the relations of f1, f2, f3, f1 is greater than f2 is greater than f3. And here also, what is the relation? f1 is greater than f2 is greater than f3. Correct? f3 is the focal length of this lens, f2 of this lens, f1 of this lens. Right? And what about the power now? Power will be P3 will be greater than P2 will be greater than P1, because focal length is greater, power will be lesser. Focal length is greater, power will be lesser. Here also the same thing. Focal length of 1 is greater means power relation will be, where shall I write? I write here only. P3 will be greater than P2 will be greater than P1. Okay. Now next what do we need to study? Relation between power and focal length over. Now we know that the focal length of a convex lens will be positive, focal length of a concave lens will be negative. Correct? If the focal length has polarity positive and negative, then power of lens also will be having that polarity positive and negative. Which lens has positive focal length? Convex lens. Remember the sign convention. This is the optical center. This one will be the coordinate axis. Correct? From optical center you are moving towards positive x-axis direction. So focal length of convex lens will be positive. So convex lens focal length is positive, so power also will be positive. You come here now. This is the optical center, right? Imagine this as optical center and this one will be the coordinate axis. Where is the focus here? Focus is here, left side. To measure focal length, you are moving towards left, negative x-axis direction. 1 second. This is not visible here like this. Oh, sorry. This one also same thing. Now see here. This is the optical center, and from here you are moving towards negative x-axis. Focus is here, so you are moving towards negative x-axis direction to measure focal length. So focal length of concave lens will be negative. When we come to concave, focal length of concave lens is negative, so power of concave lens also will be negative. So you have to understand that when they gave power as positive, it is a convex lens. Convex lens is also known as which lens? Converging lens. Convex lens is also known as converging lens. When they gave power as negative, it is concave lens. Concave lens is also known as diverging lens. Diverging lens. Okay. So this is about some theory about power of lens. And one more important thing about power of lens is power units diopter is there, right? These are SI system of unit. When we are measuring power in SI system, we have to measure focal length also in SI system only. Because in physics, wherever we go, if we are doing any equation, all physical quantities should be measured in only one system of units. Correct? This you should be knowing already. So if we are measuring power in terms of diopter, and it is diopter is SI unit of power, and then what is the SI unit of focal length? Meters. Meters. So always F should be in meters. F should be in meters. Now if what to do if f is given in centimeters? Don't change any formula. If they gave focal length in centimeters, first convert it into meters. How to convert centimeters to meters? That is already known, divided by 100, right? So first convert centimeters to meters, then you can find the power of lens. This is the best way. Unnecessarily increasing one more formula to remember and to find the power of lens is not required. Just convert the focal length which is given in centimeters into meters. After converting centimeters to meters, then you can find the power of lens. Okay, right. One more point is there about power of lens, that is combination of lens. Combination of lens. Suppose you placed, let us take, imagine that you have two lenses. One lens is not sufficient, we have two lenses. Okay, lens, this is first lens, convex lens. Okay, and this is second lens. Second lens is also convex lens only. So power of the first lens is plus 2 diopter, you imagine. Power of the second lens is plus 1 diopter. Then what will be the power of total lens combination? When they are in contact, total power of lens combination will be P1 plus P2. What will be P1? 2.00 plus P2 is 1.00. So total combination power, it will be 3.00 diopter. And what will be total focal length? Total focal length will be 1 divided by total power. It will be 1 by 3. That will be 0.33 meters. Like this. So one more formula you need to remember here is, if there is a combination of lens, if there is any combination of lens, total power if you want to find, total power total will be is equal to P1 plus P2 plus P3. Then afterwards the total focal length will be, focal length of the combination will be 1 divided by total power. Right, sir, where did we get this formula? From here only. From here only we will get this formula. Interchange these two, we'll get F is equal to 1 by P. From P is equal to 1 by F only. Okay. So you can take a snap or you can note down some important points on power of lens. Let us take some simple questions on power of lens, and afterwards we'll increase the difficulty level of the problems. Right. So first question. First we'll start with the simple questions, then we'll increase the difficulty level. If the power of lens is plus 4 diopter, find its focal length. Focal length F is equal to 1 divided by P. So focal length F is equal to 1 divided by power of lens is plus 4. Plus means what? Positive focal length. Positive focal length means convex lens. 1 by 4, it is 0.25 meter. So focal length of this lens is plus 0.25 meter. Okay, sir, understood. Now, focal length of a lens is 400 centimeters. Find its power and nature. Focal length is 400 centimeters. Centimeters they gave plus 400. Centimeters they gave. First convert it into meters. 400 centimeters divided by 100, it is going to be 4 meters plus 4 meters. Okay, we got the focal length in meters now. Now find the power. How to find power? Power P will be is equal to 1 by F. So 1 divided by 4. 1 by 4 is 0.25 diopter. Now, and its nature. Which type of lens it is? If they ask you to find the nature, you should write the nature as either converging or diverging. Positive focal length means positive power. Means positive focal length means right side. This one. Positive focal length. See? This is positive focal length. Which type of lens it is? convex lens. It will be convex lens and converging in nature. So you can write it as convex lens or converging lens. Okay. Now let us go to next question. I hope you are understanding the problems what we are doing. Everything what we do is for students' benefit only. So next see, f is equal to minus 30 cm. Focal length of a lens is minus 30 centimeters. Find its power and nature. So now focal length f is equal to minus 30 centimeters. First convert it into meters. How to convert? Minus 30 divided by 100. 0, 0 cancels. 3 by 10 it is minus 0.3 meters. So focal length is minus 0.3 meters. Now we have to find out the power. Power P will be is equal to 1 divided by F. 1 divided by focal length is minus 0.3. It will be 0.3 can be taken as 3 by 10. Yes or no? 1 divided by minus 3 divided by 10. 10 goes up, it becomes minus 10 divided by 3. So the power will be minus 10 by 3 means 3.33 diopter. So if the focal length is minus 30 centimeters, the power of lens will be minus 3.33 diopter. And what is the nature? Negative. If negative comes, nature will be diverging. See, negative comes means nature is diverging and the lens will be concave lens. So it is a diverging lens. Okay. Next, let us take some more problems. Power of a lens is 2 diopter and power of one more lens is there. One more lens is also 2 diopter. What happens to the total power and what happens to total focal length? See, there is one, when this comes to combination of lens, you should be able to understand the concept neatly. Power of lens, now in this problem they give power of lens is plus 2 diopter. Plus 2 diopter. Correct? See, plus 2 diopter. And for that they have added one more lens of power again plus 2 diopter. Again plus 2 means what? Plus means positive focal length. Positive focal length means convex lens. So for this lens, they have added one more lens. Okay. They have added one more lens of same diopter. This is also plus 2.00 diopter. They asked us to find out that combination power or the power of the total combination and focal length of the total combination. Correct? So now this lens is converging lens. Means if this lens is only there, if this lens only is there, then somewhere here they will light rays will reach and focal length will be here. Now what did you do? You added one more converging lens. Means this converging lens will induce some more converging nature into the refracted light ray. So suppose now see here, here and here. If this lens was not there, they will go and reach here like this. They will go and reach here. Correct? Now, while passing through the second lens, what happened? This lens will induce some more converging nature and they will not meet at that point. They will meet here somewhere here. Like this, the light rays will go. Right? So what happened to total focal length now? Total focal length is decreased. Correct? Total power is increased. Total power is increased. Correct? So when you add same polarity, plus and plus, if you add, power will increase. Power increases. If you add opposite polarity lens, plus and minus, what happens to power? Power will decrease. If power decreases, what happens to focal length? Focal length increases. If power increases, what happens to focal length? Focal length decreases. Right? So keep this in mind. When you add two lenses of same polarity, the power will increase and the focal length will decrease. If you add two lenses of opposite polarity, the power will decrease and the focal length will increase. Okay, na? Now let us come to this combination of power of lens formula. Problem. So now see here, Power of the first length is plus 2 diopter. Power of second length is also plus 2 diopter. We have to find the total power. What is total power formula? Total power formula is P1 plus P2. It is plus 2.00 plus 2.00. It is going to be plus 4.00 diopter. Total power we got. Now we have to find total focal length. What is total focal length? Focal length formula is 1 divided by total power. 1 divided by 4. It is 0.25 meters. Before it was 2. 1 by 2 is 0.5. Now it is 1 by 4. 0.25. Okay. Now let us solve one more problem on adding opposite powers. Now see, total power formula P total will be is equal to P1 plus P2. What is P1? 4.00 plus P2 is minus 1.00. 4 minus 1, 3.00 diopter. So total power is 3 diopter and total focal length will be 1 divided by total power, that is 1 divided by 3, that will be 0.3 meters. See now here. What happened here? If it was same polarity, 4 plus 1, 5 diopter. Power increases, focal length will decrease. What happened here? Power decreased and focal length increased. Okay. Shall we take a problem like this now? See now shall we take here this one. Power is plus 2 diopter, power is plus 2 diopter, correct? Now if I take power of the first lens P1 is equal to 2.00 diopter and power of the second lens is minus 2.00 diopter. What happens now? Total power will be is equal to P1 plus P2, that is 2 plus minus 2. It became 0. Power is 0. What happens to focal length now? Focal length F total will be is equal to 1 divided by P total. 1 by 0. It is infinity. Now where are the light rays going to meet? They are not going to meet anywhere. For this diagram, I will draw now, see once. I will draw a diagram for this question once. Let us understand. There is a lens. First which lens there? Plus 2 diopter, correct? So first convex lens is there. For this convex lens, you added a concave lens. See, minus 2 diopter you added. Means you added a concave lens like this. Exactly minus 2 diopter lens you added. Like this. One concave lens you added. Are you getting my point? Power of this lens is plus 2.00 diopter. Power of this lens is minus 2.00 diopter. What is the combination of total power now? Power of the total combination is 0 diopter. Power of the total combination is 0 diopter and the focal length of the combination is infinity. Infinity means what? Now the light rays are coming like this. Okay. And after refraction going through the two lenses, they are again going parallel. They are not bending anywhere. Like this. Okay, na? Understood or not? I hope you understood. Right? If you're not understanding and if you want me to change any methodology of my teaching, please comment and I will definitely change my teaching for your better understanding. Okay? Now next. Let us go to next level of problems. These problems are a bit complicated. These two are a bit complicated. We'll go to next. Define one diopter. We'll go to these problems next. After these two, we'll go to these problems. Define one diopter. How to define one diopter? If focal length of a lens, if focal length of lens is 1 meter, then the power of length is said to be 1 diopter. The power of lens is said to be 1 diopter. Okay, understood. Now next question. Power of lens is plus 2 diopter. Another lens of minus 3 diopter kept in contact. What is the power of the combination? See, last problem. What we did? This one. Wait. See. This also 2 diopter we have taken. This also, this minus 2 diopter we have taken. Equal power we have taken. Now what is going to happen? This is going to be minus 3 diopter. This is going to be minus 3 diopter. What happens now? Total power will be plus 2 minus 3. Plus 2 minus 3 means minus 1 diopter. Minus 1 diopter means this combination is going to work as a concave lens. It is going to work as a concave lens. Are you getting my point? Minus 1 diopter. So what happens now? These light rays will diverge like this now. They will diverge like this. Somewhere here. Like this. They will diverge. So you have to power of lens concept is very beautiful. It will be. Right? So now what happened here? Convex lens is there. Even though convex lens is there, power of the concave lens is more than convex lens. What happened now? The total combination is working as a concave lens. Total combination is working as concave lens. See, minus 1 diopter means focal length is negative from here to here. This is the focal length F. Okay. So let us solve this problem now. See now, power of the first lens P1 is equal to plus 2.0 diopter. Power of the second lens P2 is equal to minus 3.0 diopter. Total power combination P total will be is equal to P1 plus P2, that is 2 plus minus 3. It is 2 minus 3, that is minus 1.00 diopter. Okay. Now, what is the power of the combination? Minus 1 diopter. And what will be the nature of the lens? Nature of the lens will be concave or diverging. Okay, now these two questions let us solve. These two are going to be a bit difficult questions. Read the questions neatly. Focal length of a lens is plus 2 meters. As soon as another lens kept in contact, focal length of the combination is plus 4 meters. Find the power of the newly added lens and its nature and its focal length. See, I'll explain the question first neatly. After explaining the question, we will try to solve it. Okay. Right. See, first let us try to understand the question first. If you don't understand the question in physics, whatever you want to do, you will not get the answer. First try to understand the question. Right. Focal length of the lens is 2 meters. There is a lens. First of all, there is a lens. Focal length of this lens is 2 meters. When this lens alone is acting, what happened? When parallel beam of light rays came, focal length is 2 meters. Somewhere here. From here to here, it is 2 meters. Now what we did, for this lens, we added one more lens. For this lens, we added one more lens here. Here we added one more lens. I'll just take the one more lens which we have taken, which we don't know, right? We don't know. So I have taken one more lens here. As soon as I added this lens, what happened? This focal length has become 2 meters. They met here. Focal length has become 2 meters. Sorry, 4 meters. Can you guess which type of lens it will be? It will be concave lens. See, focal length increased means power decreased. Power decreased means you should be adding here opposite lens only. Opposite lens means concave lens. Correct? Yes or no? So now let us try to solve this question here. See, first focal length. Focal length 1 is 2 meters. So what will be power 1? Power 1 will be is equal to 1 by focal length 1 by 2. That is going to be 0.5 diopter. Now, what is the total focal length? Total focal length is 4 meters. So total power will be 1 by total focal length. That will be is equal to 1 by 4. That is 0.25 diopter. Now we want this lens. This lens, for this lens, what is the focal length and what is the power we have to find out. Correct? So what do we know? We know the formula for total power. What is total power? Total power will be is equal to P1 plus P2. P2 we have to find out. P total is 0.25. 0.25 is equal to P1 is 0.5 plus P2. We want P2, so send this 0.5 this side. It becomes 0.25 minus 0.5 is equal to P2. 0.25 minus 0.5, it will be minus 0.25 is equal to P2. So we got the power of the second lens P2 as minus 0.25 diopter. What will be focal length now? What will be focal length? Let us find focal length now. Focal length F will be is equal to F2 will be is equal to 1 by P2. So it is going to be 1 divided by P2 minus 0.25. 25 divided by 100. 100 goes up minus 100 divided by 25. 25 and 25 fourths. So F2 will be is equal to 4 meters. Okay na? Understood or not? I hope you understood. So from this we can write answer here as focal length of length is plus 2 meters. As soon as another length is kept in contact, focal length of the combination is plus 4 meters. Find the power of newly added lens. What is the power of newly added lens? Power of newly added lens is minus 0.25 diopter. Nature. Which nature it is? It is concave nature or diverging nature. And what is the focal length? Focal length will be is equal to minus 4 meters. Minus 4 meters. Okay, because power is minus, no? Minus 0.25 minus 4 meters. Okay, this is one of the difficult question. Now let us take one more question. This question you have to solve now. Okay, try to solve, pause and solve now. I am not going to solve for you. You need to solve this question neatly on your own. I will give you the answers for this question. Okay. Focal length of the length is plus 2 meters. As soon as other length is kept in contact, focal length as the lens has become minus 4 meters. See what happened here. Initially focal length of the lens is plus 2 meters, right? As soon as we kept one lens here, the focal length has become minus 4 meters. Minus 4 meters means what? Focal length has become this is first lens. This is already there. Okay na? For this lens we have added one more lens now. When we added one more lens, focal length of the combination has become minus 4, means focal length has become somewhere focus has become somewhere here. Like this, the light rays are going now. Parallel light rays will come until here. So, for what happened now? Power decreased. You added a opposite power lens. Power decreased. If you add more, power has went to negative also. Focal length of the combination is minus 4 meters. Okay. So total combination will be, total power combination will be, I will solve it, wait. I will give you the answer here. Let us solve this question here. First power of lens is, first focal length of 1 is 2 meters, first lens, which implies power P1 will be is equal to 0.5 diopter plus focal length of the combination, total combination is minus 4 meters, which implies total power will be minus 0.25 diopter. So we know power total will be is equal to P1 plus P2. P total is minus 0.25 diopter is equal to P1 is plus 0.5 diopter plus P2. So P2 is going to be minus 0.75 diopter. So here P2 is going to be minus 0.75 diopter, and what is going to be focal length? F2 will be is equal to minus 4 by 3. 0.75 means 1 by 0.75, 100 goes up, 25, 4 by 3. So it is minus 4 by 3 meters. And which lens it is? Which type of lens it is? It is a concave lens, or else you can also take it as a diverging lens. Okay. So this is about the power of lens from the beginning to the end, from the basic to the advanced. I have covered everything which is required for CBSE Class 10 students. I hope you understood and learned so many things regarding power of lens and combination of lenses. Thank you so much. Keep learning. All the best.